Hello and welcome to CS264. This is lecture 14 and this is lesson 1. And in this lesson I'm going to talk a little bit about solid OOP development, and I really want to talk about the single responsibility principle in this one. But before we start working with some code that we're going to apply the principles to, having revised our designs, I haven't thought about revising our designs, we need to start off with some basic program. So I decided I'd write a working program for you that does not obey the solid design principles. And the example that I took was based on an application or program that was given in this article, Solid Design Principles with C# Practical Examples, and it's from the .NET for All. And you can click through on the link in the actual piece of software here, and you'll be able to have a look at that and see how I've modified it in a way. So really we have a very simple design that calculates the total area of a list of shapes. That's the purpose of this exercise. And so we have lots of different kinds of shapes, and we looked at this in class as well. So our basic program starts off where we're interested in different shape types. And in order to be able to do this, I created this enumeration called shape type. And we have a square, a circle, an equilateral triangle, and some unknown shape type. So that was the different kind of type. Then we started off with a class called shape, and we're able to say all shapes have some width in some description. And in other words, they have a single attribute that we use to be able to describe the width. And once we have that, we're able to describe the area. And with a square, it's a length of a side, and with a circle, it's the radius, and with an equilateral triangle, all sides are the same. So we really need to record one instance variable here in this class. So we also start and say that this particular shape has a shape type, and initially it's defined to be an unknown shape from here. And then when we create a shape instance, we're able to tell it what the shape type is and what the width is in this case here. And we're able to assign the values that are passed to the constructor here, and adding them to the instance variables here. One is private and one is public, just because it is. Now we have a method in here as well that calculates the area of the shape. Okay, and so what it does is just this public method that gets the area, and it switches the type. Okay, so it investigates the type of shape, and then if it's a square, it calculates it using this formula. If it's a circle, it uses this formula, and pi r squared. And if it's this form, we use this formula. Okay, if it's an equilateral triangle, and then we just throw an error because we can't compute the area of the shape. Then we have a method in here, and we suddenly have a static method, and this calculates the total area and takes a list of shapes. And then once we initially set it up to have the total area being 0, we calculate the total area by iterating over all shapes in the list, and then we call the getArea method from the shape, and then we write out the total area. So our program then tells us a little bit about what's happening here with solid and development, and this is our working bad design, okay? And a little bit of a description here just so you have it. We create a shape, which is a list, and we have some shapes. We're calling it the shapes, creating a new list of shape. And remember, we're using the generic collections up here in order to be able to use lists. Creating a new shape, which is a square with 100 as the width, circle 100, it's another square with 200, and a shape which is an equilateral triangle for 100. Then I calculate the total area of the shape by calling that static method called shape calculate total area. So this is the program. It's a bad design. It works okay for us, but it's not good. Okay, and sometimes I think at this stage it's hard to write a bad program when you know how to write a good program. But there's loads of bad things about this. But from the start, I wanted something that would violate the single responsibility principle and also the open close principle. So I could use the same example across the two. So let's run the program though. I'll save this and let's run the program first. So let's open a terminal here. And it's in a directory called first design. So we'll go there. Let's give ourselves a little bit more space. First design. So we should get all the output that we saw earlier, and we get the total area. It's been calculated 62184 point whatever. Okay, these are all doubles, and again, so we were able to get this information. So the program works, and it's a working bad design, and it's fine. So we now have something to work with, because we want to improve on this. Let's close this. So the first issue that we're interested in looking at is the single responsibility principle, the SRP. And that tells us that a class should take one responsibility, and there should always be one reason to change that class. So what we're going to do is going to rework the example that we have earlier. So we start looking at having a single responsibility for each class. That means, first of all, we've got to break the class into some extra classes. I'm going to keep some of the original design like this enumerations here. We'll look at that a little bit later. But we're going to start with the first design and work on the SRP and the total area calculation, because the big issue initially is that, the class shape didn't just manage and tell us about shapes, it also calculated the area of all shapes and not just calculating the area of an individual shape. So it had two responsibilities here. So the best thing to do is to move the responsibility for calculating the shape. So this was the method that was in here, and calculate the total area. And we're going to remove that from this shape class into a new class. So the shape class just handles shapes and individual areas, meaning there's some kind of single responsibility thing going on here in the shape class. So that's good. Okay, so we have that initially. So what we want to do then is we want to actually create an area calculator class, knowing right that this violates the OCP, okay, which is the next principle. But we're going to do it anyway, and we'll fix this later, okay? But what's important for us is that it helps us with the single responsibility principle. Okay, so we create this new class called area calculator, and and so we have, first of all, let's show you what a method looks like in order to be able to do a bad version, okay, of, even though we created this, it's still bad because we want to have the single responsibility. So we've separated the method out. Remember, we had it here. It calculates the area and then writes the area to display. And that's the problem, because it does two things. It calculates the area and writes the area to display. So even moving it to a new class called area calculator doesn't really help things for us, because we still have this method that does two things. So the class itself is essentially doing things because it only contains the static void method that calculates the total area and of a list of shapes. And I'm calling in this one the calculate total area bad. So you can see, even though it works, it has two tasks and it writes the two. So that's what's bad about it. The better version, or the final version, would be to calculate the total area and just return the total area. So instead of having the static void method that takes the area, the shapes, calculates the area and writes to the display, we just take the list of shapes, return the actual total area. That's better. So really, for a proper working example, we just comment this or remove it, in fact. But if you just want to check for yourself, you could comment it. So that means then we have broken our class, original shape class, into two classes, the shape class, which just deals with shapes. It doesn't do that very well, but we'll see that in the next lesson. And then also an area calculator class that does some area calculation. And we could see that if we just split them, it wouldn't be good enough. We'd still have the problem where we have this area calculator class working on calculating the total area and outputting the information. And that's not good enough, because we might want to output in different ways. So the final version then, of course, is just to use this one here. And so what we've recommended, and I said in the last lectures, well, we really should have an output formatter, so that, if we wanted to change the way the way we wanted to output to be, for example, in JSON format or text format or HTML format, we'd have to change this line here in the bad example. So we don't do that. We actually create another class called the public output formatter class, and that allows us to be able to create whatever's sent to us, a number in JSON, so it's another static method, or HTML, or to text. So this only handles format. It just takes data and handles a format. So in our program then, we can create a list of shapes, again, exactly as we had previously. It's not great design, but we know it's not great design, and we worry about it in the next lessons. So we can calculate the total area just using the method, okay? And it's the bad method, okay? We're just calling it, it's still bad, right? Because it's doing two things. It's calculating and printing. Or we could just calculate the total area of the static method, calling it, and this is better, because we then, have this created here, okay? So we have this returning this total amount of area associated with shapes, and we're writing it in here. But again, if we wanted to, this is the program class, okay? But if we wanted to do something else with this, or change how it's formatted, we'd have to add another line or separate line. So really what's better is to use the output formatter, where we can just use our new area calculator, calling this method that calculates the area and then print it as JSON, HTML, or text. And this is a much better setup and arrangement of our original program that is in line with the single responsibility principle. So I'm very happy with this one. Well, I'm happy that it does this. I'm not happy as far as that it breaks all sorts of other principles, but for this one, it's pretty good. So let's just run this program again. Let's open a terminal, have a new terminal, and this time we'll go into CD SRP. And we're here, SRP. Let me just make this a little bigger so we can see. And now we'll run this one. Okay, and we have the total area, which is what we would expect. We had the bad one and the correct one. Okay, so let's just quickly go down to the program here. So we did it the bad way because that was still hanging around inside our class, our area calculator class. And then we did it the better way, which is this better way here. And but then we did it the best way, which is we handled all the outputting using a separate class. Okay, and that was the best way, and we show how we can do it 3 different ways. In fact, we could just have calculated the area once and then send it through. That would be better design again, but we some limits on what we're trying to do here. And here we have the output in JSON. Here we have the output as HTML, and we have the output as text. And that's it for us, really. It looks good. It looks better. And what's more importantly is that we've looked at producing a piece of software, and we've updated a piece of software here that allows us to be in line with single responsibility principle. We'll talk about the open close principle in the next lesson. Thank you very much for watching.